Okay, for our second part of class today, we're going to talk about angled projectiles where they don't land at the same height they started at. So, title this section, Angled Projectiles, where delta y does not equal 0. So let's take our first example here. We've got a projectile that's going to be launched at a 70-degree angle at 60 meters per second down here on the ground, and it's going to land somewhere that is 20 meters above where it's shot from. So before we even ask any questions here, the first thing you should be thinking of doing, break this vector into its x and y components. 60 times sine of 70 gives us our VIY. That's 56.38 meters per second. 60 times cosine of 70 degrees gives you the x component, 20.52 meters per second. First thing, let's figure out what is the maximum height. Maximum height that the projectile reaches above the surface it was shot from. Above where it is shot from. So we list our variables that we know. In the y direction, our acceleration is negative 9.8 meters per second squared. Our initial y velocity, 56.38 meters per second. At the maximum height, you know your final y velocity at that maximum height is 0. Look for delta y. So Vf squared equals Vi squared plus 2a delta y. 0 equals 56.38 squared plus 2 times negative 9.8 times delta y. Do a little algebra. Your delta y above where it started, 162.2 meters. Next question, flight time. Total time this sucker is in the air. Initial y velocity, still 56.38. Acceleration in the y direction is still negative 9.8. We know that it's going to land 20 meters higher than it stops, or where it started, excuse me. So our delta y for the total flight is 20 meters. We're solving for t. So delta y equals VIY times t plus 1/2 at squared. 20 equals 56.38 t plus 1/2 negative 9.8 t squared. Dun dun dun, got to use the quadratic equation. So get everything on the same side. You get 4.9 t squared minus 56.38 t plus 20 equals 0. Show me somewhere that you use the quadratic equation. We get a time of 0.366 seconds, as well as a time of 11.14 seconds. You might be wondering, why do we have two positive answers here? Well, this thing is going in a parabolic trajectory, so the 0.3 seconds is the time that it's 20 meters up on the way up. 11.14 seconds is when it's at 20 meters on the way down. Okay, it's a parabola, so it's going to be at 20 meters twice. Next question, I want to know the range. So to find the range, aka delta x, we need our x velocity times the time. Our x velocity from the triangle we already found is 20.52 meters per second. And we just solved for a flight time, 11.14 seconds. By the way, we never actually picked which answer from the previous question was correct. When it lands, it's after 11.14 seconds. 0.3 seconds is not enough time for it to land. It's just on its way up. So again, solving for the range, multiply our velocity in the x direction by time. You get 228.6 meters. And last but not least, if I wanted to know the speed upon impact, so when it lands, how fast is it going? Again, draw your little vector, break it into its x and y components. We already know the x component is 20.52 meters per second. You can use kinematics to solve for the final y velocity. I'm going to skip ahead to that. We know it's going to be 52.8 meters per second. Again, I'm just going to skip the algebra there. Use the Pythagorean theorem to get this hypotenuse. You get 56.6 meters per second. That's how fast it's moving when it hits the ground. If you want to know at what angle, you'd use trig to solve this data. Hopefully, between this video and the last video, you now know enough to be able to solve some angled projectile problems on your own. Good luck. We will be whiteboarding on Thursday.